Okay, so welcome to our third virtual session on advanced engineering mathematics. So you have already submitted your names on the group chat. For those of you who cannot submit your names using group chat, then you can also use our group chat, our group chat in the messenger for our attendance. Okay, so our topic for this evening is the complex form of a complex number. So we are the last topic, we are considering the form of a complex number, which is the rectangular form. Now we will be considering the complex the polar form of a complex number. So for example, the form of our complex number, the usual form is x plus j of y. So this is our rectangular form. Okay. Then if we are going to have this one in the polar form, so the polar form involves the absolute value of our complex number and the argument or the angle. So if we are going to plot our x and y in an x and y coordinate system, okay, also known as the Cartesian plane. So for example, this is our x, this is our y. So if we are going to have here, this is x sub 1 and y sub 1. So this is our x sub 1, this will be our y sub 1. Okay, so this will be the point at which our the coefficients or the real and the imaginary part of our complex number will fall. So this is x sub 1, y sub 1. Okay, so if we are going to draw a line here, okay, so this is now we call as the absolute value, that is the r, and we have an angle here theta, which is the argument of our complex number. So the polar form of a complex number is given or is written as r angle theta. So we're in r, this is the absolute value, and our theta is the argument. Okay, so how to solve for r? So if we are going to solve for r, this is just a very basic Pythagorean theorem. So our r, so this is, if we are going to transpose this one, this length, so this is y sub 1 also. So we could say that our r is equal to the square root of x squared. In this case, that will be x sub 1 squared plus y sub 1 squared. Okay, then we could also say that our theta, okay, solving our theta involving our x sub 1 and y sub 1, that will be arctangent or inverse tangent, that will be opposite over adjacent, so that will be y sub 1 over x sub 1. So this is now how we are going to get our polar form of our complex number. Okay, so for example, we have here this rectangular form of our complex number. For example, we have 7 plus j of 5. So we are going to convert this one into r theta or the polar form. Okay, so to convert this one, so we just first get our r. So our r is equal to the square root of this one. I use x sub 1 and y sub 1, but we could use x. So our x is our real part and our y is our imaginary part. So in this case, our x is 7 and our y is 5. So we have r square root of 7 squared plus y squared. Oh no, 5. Okay, sorry for that. This will be 5 squared. So you have your r is equal to 49 plus 25. Okay, so we will be using our calculator. So let's just have first our calculator in the screen. Okay, let's just adjust first the... Okay, so we have now our calculator on the screen. So that will be square root of... Okay, so maybe I will reset the... Okay, so we have square root of 49 plus 25. This is equal to square root of 74. Okay, so our r is equal to square root of 74. Then our theta, so our theta is inverse tangent. This will be y over x. Okay, so we have inverse tangent. Our y is 5 and our x is 7. Okay, so we will now be using again our calculator. Okay, so we have, okay, we have shape, tangent, so this will be 5 over 7. Okay, so this will be equal to 0.62. Okay, so 0.62. Okay, so this will be on radians. Okay, so 0.62 radians. Okay, so we could now rewrite our given complex number in the form, okay, in the form, the r is square root of 74, angle of 0.62 radians. So we are in getting the complex, the polar form of a complex number. We'll be using the unit for angle as radians. We could also have another another notation for this one. For example, we are going to have this one in the going back to the rectangular form. So our z will be equal. It will just be equal to r. We are just right below to have distinction in the discussion. Okay, so okay, so if for example we are going to convert a polar, so polar to rectangular form of a complex number. So for example, the given is r angle of theta. So the way of converting that one is we have z, so this is the notation for our complex number. That will be r times cosine theta plus j sine theta. So this is how we are going to convert the rectangular form, because this r cosine theta, if we are going back to our x and y coordinate, so we are going back this one. So if this is our complex number z, okay, this is z here. So this is x, now this is y, and this is x, this is our theta. If we are going to solve for x, so x is equal to r, this is our r, cosine theta, and our y is y is equals to r sine theta. So that's why in converting polar to rectangular, we'll be solving x. This is for x, and this is also the r, and the sine theta is for y. Okay, so that's why this z is equals to r cosine theta, quantity r cosine theta plus j sine theta is also equal to x plus j of y, wherein our x is equal to r cosine theta, and our y is equal to r sine theta. Okay, now in this plotting, or the x and y coordinate, or the x and y axis that we are plotting using the plotting of our complex number. So this is this type of Cartesian plane is also known, if you are now considering complex number, this is what we call as the Argan diagram. I believe this is covered by the the calculus. Okay, so it's just so this is not we called as the Argan diagram. Okay, so let's try an example in which we are given with a polar form. So for example, 5 angle of 0.63, so rads. Okay, so we will be converting this one into the x plus j of y form, or the rectangular form. Okay, so this just have this one as z is equal to r cosine theta plus j sine theta. So substituting here, this is our r with another call. So this is our r and this is our theta. Okay, so we have 5 cosine, our theta is 0.63, plus j sine 0.63. Okay, if you are going to have this one in the calculator, so we have 5 cosine theta, or 5 cosine 63, so we have 5 cosine 0.63. So just a reminder, so because our angle is in radians, we must set our calculator also in radians. Okay, so I believe the calculator was not seen on the screen. Okay, so we must set also our calculator in radians. So this one r. So in doing this one, if you're using a Casio calculator 570, FX 570, so you just need to have press shift mode, then 4. So 4 is for the radians. So 4. Okay, and now the setting of your calculator, the degree, the unit for the angle is in radians. Okay, so 5 cosine 0.63, that will be 4.04. Right here, 4.04 plus j 5 times sine 0.63. So 5. So the 5 here will be distributed to each term of this of the cosine and sine. So we have sine 0.63. This is now equal to 2.95. So plus j of 2.95. So we have converted a polar form of a complex number into a rectangular form. Okay, next we will be discussing the multiplication. Okay, so we have just multiplication on division and division of complex number in polar form. Okay. Okay, so for the multiplication, so if you are going to have the multiplication, so for example, we have two complex numbers. So z sub 1 is equal to r sub 1 angle theta sub 1, and z sub 2 is equal to r sub 2 angle theta sub 2. Okay, So if you are going to have z sub 1 multiplied by z sub 2, so the formula for that one is r sub 1, r sub 2, angle theta sub 1 plus theta sub 2. So this is the formula. If you are going to have this one in division, so z1 over z2 is equal to r sub 1 over r sub 2 angle theta sub 1 minus theta sub 2. So it's much easier to have the multiplication in polar form and the division in polar form than in the rectangular form, because if we are going to have our multiplication in the rectangular form, we will be using we are multiplying two binomials. If we are going to have division in rectangular form, then we will be getting the conjugate of our divisor. So much easier if our complex number is in polar form, because we are just, for the multiplication, we are just multiplying the absolute values of our two complex number and adding their respective argument or their angle. For the division, so we're just dividing the absolute value and subtracting the argument of each of the given complex numbers. Okay, so to illustrate this one, we will have some examples. Maybe I will just be looking some examples here in the book. Okay. Okay, so for example, we have this given example. Okay, so our not x but y, z sub 1 is equal to 9 angle of 2 radians, and our z2 is 7 angle of 0.45. Okay, so we need to find first our z sub 1 over z sub, just first the multiplication, z sub 1 times z sub 2, and we have the division z sub 1 over z sub 2. Okay, so we will first get a, this will be our solution. Okay, so our z sub 1 times z sub 2, so this is equal to, our r sub 1 here is 9, so we will just write here the r sub 1. R sub 1 is 9, this one. Our r sub 2 is 7. Our theta sub 1 is 2, which is radians. And our theta sub 2 is 0.45, which is also in radians. Okay? Then, let's just use the formula. So we have r sub 1, r sub 2, angle theta sub 1 plus theta sub 2. Then it's just substitute the givens. We have 9 times 7 angle 2 plus 0.45. So we have 9 times 6, that will be 63, and 9 times 7, that will be 63, angle of 2.45 radians. So this is now our answer for part A. So for part B, so we have Z1 over Z2. Okay, so this is equal to R1 over R2 angle theta 1 minus theta 2. Okay, so our R sub 1, that will be 9, our R sub 2 is 7, angle, so our theta sub 1 is, just look back, so that will be 2, so that is 2 minus 0.45. So 9 divide 0.45. I believe it is now, it was, okay, so sorry for the black of the calculator. I forgot to turn off the screen for the calculator. Maybe I shall move this screen over here. Maybe the calculator. Let's just move the calculator. Okay. Okay, so oops. Okay, just move the calculator over here. So we will now be using our calculator in solving this one. So that is 9/7. So 9 divided 7. This is equal to 1.29. 1.29. Then we have 2 minus 0.45. So this is equal to 1.55 radians. Okay. This is now our answer. Okay, so the last part of our discussion for this evening is the power of a complex number. Okay, so the power of a complex number, so the power of a complex number is given by the formula. So first you must express your complex number into polar form. So the power of a complex number z to the n is equal to r to the n angle n times theta. Okay, wherein your n here is the exponent or the degree in which you are raising your complex number. So for example, we have 3 plus j of 7 raised to the power of 5. Of course, you can do this one, multiply the complex number by itself 5 times and you will have a tedious solution, or you could just convert this one into a complex number convert this. So first need to get your r. So your r is square root of 3 squared plus 7 squared, and your theta is inverse tangent, that will be 7, so that is y over x, so 7 over 3. Okay, so we will have, maybe I will just have my calculator again. Just put our calculator on this side, then okay, so we have square root of 3 squared plus 7 squared. So this will be equal to square root of 58. Square root of 58. Then for the argument or the angle, so that is inverse shift tangent 7 divided 3. Okay, so this is equal to 1.17. So we have 1.17. Okay, so if we are now going to express our given into polar form, so that will be equal to z is equal to square root of 58 angle of 1.17 radians. So if we are going to raise our z into 5, so we will have square root of 58 raised to the power of 5 angle 5, because our 5 here is the n, times 1.17. Let's just write this clearly. 1.17 radians. Okay, then we will now have our answer. Okay, so square root of 58. Okay, so raised to the power of 5. This is equal to 25,619.46. So 25,619.46. Okay, then shift tangent 5, that is just 5 times 1.75 times 1.17. This is equal to 5.85. So angle of 5.85. We are going to convert this one into the rectangular form. So z to the power of 5 is equal to 25,619.46 cosine 5.85 plus j sine 5.85. Okay, so we'll now have, so again, always remember that our calcu must be in radians. Okay, so we have 25,619.46. Okay, cosine 5.85. Okay, so we will have 23,253.07. 253.07 plus j of, so sine, so we replace this one with sine. Okay, sine. So we'll have negative, so that will be minus. Okay, so we will have minus. Okay, so it is negative, so we just erased here. Minus 10,754.13. 10,754.13. So this will now be our answer. Okay, so there is also a shortcut in the calculator in doing this one. For example, if we are going to convert our rectangular form into polar form, so for example, we are given with 3 plus 6i. So the shortcut for that is, first you must have your calculator in the complex mode. So let's begin from the beginning. So shift mode, then go to complex. So there will be 2. Then you input your rectangular form. So 3 plus 6i. Then shift complex. So that is 2. Then 3. So you press 3 equals. So that will be now this will now be the polar form of our given rectangular form. If we are going to have this one in reverse, for example, we have 3 angles, so this will be our angle of 0.45. So our given, the given is in polar form. We're going to convert that one in rectangular. So just have shift 2, then 4. Your answer will be in rectangular form. So that is the shortcut using the calculator. So we could also have, maybe I believe, up to 3, 3 for the power of a complex number. Let's try. So 6i raised to the power of 3. Okay, so 3. Let's have 5. Okay, so 5. Maybe we will have, so how about the limit 99? Okay, so it could be up to the power of 99. So that is how we are going to get our complex form and doing the operations using the polar form of a complex number. Okay, so as for your exit attendance, so I will be showing you here a very simple problem which you are going to convert a complex number into its polar form, and for your answer you just chat your name on the group chat and the letter of your answer. Okay, so this will be the problem. Convert 4 plus j of 3 to polar form. Okay, so you have until maybe 15 minutes to submit your answer on our group chat. So you have to convert 4 plus j of 3 to polar form. So you only need to submit your complete name, and after that the letter of your answer, and that will be for your exit attendance. So you have 15 minutes to answer. And if you have also any question, you can also chat in our chat box, live chat, or in our group chat. Okay, so I will be waiting for your answer. Okay, so the given is 4 plus J3. No, not 2 but J3. So we will just rewrite this one. So that will be 4 plus J3. Okay. Okay. So that is 4 plus J3. Okay, so for those of you who have already submitted, so thank you for your submission. And for those of you who are not yet through, so you can still submit your answers. So I'll just end up this discussion for this for tonight. And next meeting we will have our another quiz for this topic. So thank you for watching. So thank you for listening. And if you have also questions, so you just the group chat is still active. So have a good night.